Hi, this is Kidney Caliper, a fully automated deep learning-based workflow for kidney pathologists. Traditionally, pathologists will look through a microscope to examine kidney tissue extracted from a biopsy. Their analysis of the tissue is used to help predict the survival rate of the donor kidney in the recipient. Nowadays, the examination process is improved by taking very high-resolution digital images of extracted tissue. This is a big improvement over the traditional microscope, but pathologists are still left to annotate upwards of 1,500 features of interest by hand. This is a very slow manual process, and as a result, pathologists must compromise and prioritise annotating some features of interest over others. This limits the scope of their analysis and provides researchers with less information to use when reasoning about the survivability of the donor kidney.
Kidney Caliper solves this with a dramatically faster workflow for pathologists. All features of interest in a kidney scan are automatically annotated, even those that pathologists didn't usually have time to annotate. And measurements and analyses that were practically impossible to capture manually are now obtainable. Finally, researchers now have much greater insight into finding out what factors make a difference in donor kidney survivability. Now, let's see this tool in action. You can follow along by visiting the URL in the bottom right.
Starting from the upload page, we can upload one or multiple images at once. After uploading, you can view thumbnails of each image along with all relevant metadata, including the date scanned, original file name, and the scanner used to capture the image.
Once the scan has passed through the two deep learning models, the annotated image can be viewed on the results page. The image has been annotated with the different regions of the kidney and all of the features of interest within the scan, like the arteries and the glomeruli that you can see here. Users can view the numbers of each feature identified and can also plot a scatter graph of any two measurements against each other, filtering by features of interest, to give them the maximum flexibility over the statistics that they can gather. Research has shown that the areas of some features could help to predict patient outcomes. However, this cannot be calculated by hand, so this is a particularly useful statistic that can be visualized on the scatter plot. Annotations can be filtered by both their feature type and kidney regions, as identified by the two models. Clicking on an annotation displays the measurements that have been generated for it. For example, the dimensions and computed area for each annotation. Inaccurate annotations, like these two glomeruli annotations here, can be deleted, and new annotations can be created using either the polygon or freehand drawing tools.
The statistics and annotations generated by the program can also be exported by the user. The annotations can be exported in either the W3C web annotations or GeoJSON format. GeoJSON is particularly important as this makes the annotations compatible with the QPath application, which is currently used by pathologists to view annotated medical images. To improve user experience, we have included help dialogues to guide the user throughout the application and help new users understand the application's capabilities. In addition to generating individual slide statistics, the cross-comparison page allows users to compare aggregated measurements across multiple scans. Using the file picker, users can select which scans they would like to compare, filtering by date. Users can then plot any two arbitrary measurements against each other.
Now let's hear what researchers have to say about Kidney Caliper.
Hi, my name is Callum. I'm a digital pathology research assistant at Imperial College London. The Kidney Caliper application has essentially sped up my workflow at 1000%, because previously we had a set of deep learning models that were optimized from a research point of view, but not from a production point of view. You can see all of the analysis results, and you can also download this into different types of formats that are compatible with both open source software that pathologists use routinely. This is going to provide me with a ton of data to analyze further down the line.
Hi, my name is Dr. Candice Rufos. I'm a senior clinical lecturer and NHS consultant cellular pathologist. Kidney Caliper could save me time by performing the mundane tasks for me, and it could also measure and provide statistics on all kidney structures, providing patients with the best possible information on the state of their kidneys.
With support for comparing statistics from previous run kidney scans, being able to quickly modify annotations, and even being able to export the results into familiar software, kidney pathologists are now well equipped with a set of tools that will give them a richer set of information in a shorter time frame compared to what was possible before. Researchers like Candice can now have more information at their disposal, which they can use to better inform the decision to accept or implant the donor kidney. This means Kidney Caliper has the potential to have a legitimate impact on improving the survival rate and longevity of donor kidneys in recipients.